Hello Internet. Today I want to show you the demo of my open source project called Dodo. It is a platform as a service solution which abstracts away all the complexities related to maintaining production grade infrastructure and exposes easy to use primitives to its users. Dodo can help you take your project from an idea stage to actually deploying it in production without ever leaving the Dodo environment. To demonstrate its capabilities, let's build the basic blog engine from scratch. In the process, we will ask Dodo to create a cloud-based development environment, provision persistent storage, secure some of our application's HTTP endpoints with built-in authorization service, and finally publish our application globally. Let's choose to run our blog inside the private network, expose it on blog subdomain, and let's use the Next.js framework on top of Dino 2.0 runtime. As you can see, Dodo has created an application-specific Git repository for us, which we can clone on our local machine and look inside. Since we picked Next.js as a starting point, we see all the familiar files here. There is also an additional Dodo-specific configuration file called app.json, which instructs Dodo what our application environment should look like. For now, let's leave it as is and we will come back to it in a bit. Status page lists the full commit history of our application, which for now contains only one initial commit created by Dodo itself. And our application endpoint. Let's open it up and there we go. Dodo has successfully provisioned and deployed our blog. To demonstrate how easy it is to deploy new version, let's change the homepage and push it upstream. Status page shows that Dodo has picked up the new commit and our application now renders the new homepage. We could end our demo here, but let's explore another powerful feature of Dodo. Obviously, we can continue product development on our local machine, but Dodo can provide us with a cloud-based development environment as well. Let's create a dev branch and see what we get back from Dodo. Status page looks a little bit different now. Development branches behave like a regular branch with one major difference. Dodo, instead of automatically deploying and running our application, it provisions a virtual machine for us, which we can log into, make any changes in the code, and run the service manually. Dodo has created a branch-specific domain for us and also gives us another address pointing to the VS Code server running inside the VM. Let's open it up and continue development there. VS Code is running inside the private network and I am automatically authenticated with it since I'm already logged into the Dodo VPN. Dodo is application type agnostic and automatically pre-installs all the necessary tools on the VM that users might need to work on the project. Since we picked Dino as an application runtime, our VM comes with the Dino tooling. Dodo has made a couple of changes in the app.json file. It has defined development section, which we can do manually as well in any branch, and updated the subdomain. Here I removed the default Next.js style sheets, add Pico CSS as a dependency, and update the layout. Let's start the Next.js dev server manually and open up the branch-specific endpoint of our application. Basic skeleton of our application is up and running. Let's commit changes we made up to this point. Now we need to figure out where to persist the individual blog entries. We can leverage Dodo's another capability here and ask it to provision PostgreSQL instance for us. To achieve that, let's update the configuration file and add a PostgreSQL section to it. For Dodo to fulfill our request, we must commit and push changes to upstream. If we reload Dodo environment variables, we can see that we get the connection URL of the provisioned PostgreSQL instance there. To communicate with it, let's first install the Prisma library, then install the Prisma extension to get syntax highlighting, and finally use the Dodo provided environment variable as a data source connection URL. Let's define blog post entry model and ask Prisma to generate database tables and client interfaces for us. Now that we have entry table ready, let's add the new blog post creation route handler, update the homepage to list all the blog posts, and implement entry by ID handler so that we can view the individual blog entries. Let's see our recent changes in action. Now that we have basic implementation ready, let's think about the security. Obviously, we don't want any unauthorized user to be able to create blog posts. We could roll out our own custom solution or use any existing external service, but Dodo reduces friction here as well. To enable application-wide authentication, all we have to do is change this one variable in the configuration file. Note that I'm doing all of this without restarting the running application service. Since I'm already logged into the Dodo, I can continue using the website. But if I open it up in the incognito mode, then I'm automatically redirected to the authentication page. Let's update configuration file so that the authentication is only required to create new blog posts, meaning homepage and individual blog entry pages must be accessible by anonymous users. To achieve that, we can define a list of regular expressions matching routes which should bypass the authentication. Behind the scenes, Dodo runs authproxy in front of our application and injects authenticated user details such as user ID, username, and list of transitive groups it belongs to as a custom HTTP headers. We can use that information to associate every blog post with the user who created it. Let's first update the Prisma schema and add an author field to the entry model. Next, get the authenticated username from the HTTP headers and persist it in the database with the new blog post. We can also update the individual blog entry page handler and include the author next to its title and contents. Let's see recent changes in action. We can tighten security even further. What if this is our company's official blog where only PR team members should be able to create the content? Let's leverage Dodo's built-in group membership service here and put privileged group name in the configuration file. Dodo, to act on this change, let's push it upstream and see what happens. Now I am getting an unauthorized error. And if we go to the PR group page, we can see that it has no members. But since I am the owner of the group, I can add myself as a member, which will grant me access to the create form. Okay, looks like we have reached a pretty good point in our development process. We can now publish our blog globally. Let's merge changes from dev branch into the master and modify Dodo configuration file a bit. We must remove the dev section to make Dodo deploy our application automatically, instead of us running it manually inside the VM. And since we are handing over responsibility of running the app to Dodo, we should automate running Prisma migrate scripts as well. We can define pre-built command section and push changes upstream. Note that since this is the first time we have requested PostgreSQL resource on master branch, Dodo has provisioned fresh new PostgreSQL instance for production and our blog will be empty. Let's open up the master branch endpoint and say hello to the internet to double check that everything works. Now to make our application accessible globally, we can migrate it from the private to the public network. Note that Dodo uses Let's Encrypt to secure all of our applications via TLS certificate. Okay, to sum it up, we saw how Dodo can help us in every step of the development process and productionizing applications. Since application branches are completely isolated from each other, you can create clones of your production environment and debug issues or experiment with new ideas without affecting production customers. Its cloud-based development environment can help you onboard new team members and make them productive from the very moment they join the project. You do not have to wait for days or even weeks for their physical machines to be ready. We saw only one of the core functionalities of Dodo. We looked at how new applications can be developed using it and on top of it, but Dodo is actually much more than that. You can think of it as an operating system of the cloud, which comes with its own app store with open source standard of packaging and publishing applications. This will enable third-party developers to publish their work and get paid for it. Installing apps from the App Store is as easy as on mobile devices. You can target Dodo platform from the beginning if you are building a new service, but existing solutions can easily be adapted to it as well. I have already ported multiple open source projects to this ecosystem and have been using Dodo to develop Dodo itself for the past half year or so. For example, you can install Matrix server from the App Store to do the real-time communication, Gerrit for code reviews, and Jenkins for CI/CD. As I mentioned earlier, Dodo is open source and code is hosted publicly on Dodo itself, but I don't want to advertise its location until I figure out the licensing details. Once that is done, you can of course download the source code, do the audit, and deploy it on your own or rented hardware. Dodo comes with the bootstrapping tool, which takes IP addresses of your Linux servers and installs its own fault-tolerant cluster on top of them. I am also hosting the paid version of Dodo, which I plan to use to fund the development of the project and also share the income with the open source solutions it is built on top of. It would be great if Dodo with its App Store could be part of the solution to fix the open source funding problem. Now let's make a brief comparison with the similar products. There are quite a few of them already on the market, but I would say Dodo is much higher level and flexible than any of them, and can significantly improve your productivity and efficiency. While you can dig deep inside Dodo and affect every aspect of your infrastructure, in most cases I would say you don't really need to do that, and Dodo makes your day-to-day tasks much easier. Also note that Dodo does not actually require you to install any Dodo-specific tools on your workstation. It gets out of the way and lets you do the work with the tools you are already used to. The only Dodo-specific thing we had to touch during the demo was the environment configuration file. There are solutions which provide you with a fault-tolerant storage, but usually they don't really touch the CPU redundancy topic at all. There are products which are kind of walled gardens trying to promote their in-house technologies, which is their prerogative, and as long as you stay within those predefined boxes, you are good. But if you decide to pick outside, then you are out of luck. You have to first find some external solution and then figure out how to tie it up with your existing infrastructure, if that is possible at all. There are other open source solutions which I would say are as flexible as Dodo in terms of managing low level infrastructure, but they don't really go much higher level than that. So I would say they are more comparable to having a nice UI on top of the raw CLI tools. While Dodo absorbs all the details and does not leak low-level infrastructure concepts to higher-level applications. If you are interested in trying out Dodo, learning more about the technical details of how all of it actually works internally, or what to get involved in the project, I would be more than happy to chat with you. You can find my contact information in the details, and I would love to hear from you and get some feedback. I'm also including the link to the podcast where I go deeper into the implementation details. If there will be enough interest, we could even maybe organize a community meeting, which would be great. Please reach out to me and let's go from there. Thank you for listening and cheers.